Hi everyone, we need to solve this log equation. To get rid of a log base 2, we'll need to exponentiate with a base of 2. So I'm thinking if I raise 2 to the log base 2 of x squared plus 5x plus 10, that should equal what I get when I raise 2 to the 4. On the left-hand side, the 2 and the log base 2 cancel. Remember, that has to be an exponential base 2 and a log base 2. If you're multiplying, it doesn't work. It's that exponential log thing that's inverse. So all I'm left with is an x squared plus 5x plus 10. Be careful on the right-hand side. Actually, it wouldn't matter here, but sometimes people reverse this and they do 4 squared instead of 2 to the 4th, and that can definitely cause you problems. This is a weird one where those two are the same thing, but usually they are not, so watch for that. This is quadratic, so we want to set it equal to 0, so next we're going to subtract 16, and we'll get a x squared plus 5x minus 6 equals 0. That does look factorable, so we're going to split it up, x and x, and then we've got a negative 6. So factors of negative 6 that add up to 5, I think I want a plus 6 and a minus 1. So either x plus 6 will equal 0 or x minus 1 will equal 0, which means x is negative 6 or x is 1. Okay, this was a log equation, so we do need to check. This is that non-optional check. And really what we're checking here, you can do a full check to make sure that you are right all the way, but the extraneous check is just to make sure that there's no negatives inside of the logs. So if I do negative 6 squared plus 5 times negative 6, so that's going to be minus 30, plus 10. Okay, so 36 minus 30 is 6, plus 10 is 16. That is greater than 0, so I shouldn't be having any problems with that one. And then 1 looks like it should be fine as well. 1 plus 5 plus 10 is positive. So I actually get to keep both solutions this time. All right, this second one is exponential, so we've got to go the opposite way. Here, we're trying to get rid of an exponential with a base of 10, so we're going to take a log base 10, common log of both sides. And if you're comfortable and don't need to show this step, that's okay. Just make sure you're very clear on what's happening. If you don't have that understanding of what we're doing in that step, it's just memorization and it's not going to stick with you. So the log base 10 and the 10 to a power cancel each other out. I'm just left with the x squared minus 1 equals log of 24. This one is an interesting one. I don't think I'm going to be able to factor with that log of 24 floating around, but do be aware that is just a constant. We don't have to do anything to get rid of that log. It's just the log of a number. I do notice that I have an x squared but not an x in this equation, so this is a good one to solve with square roots. You can add the 1 to the other side, and then you can take the square root of both sides. Do not forget your plus or minus. And I'm going to throw in parentheses here just to make it maybe a little more clear that I can't add the 24 and the 1 and say that's log of 25. You can't add something into the inside of a log. So those are my two answers. This started out exponential, so I'm not worried about extraneous solutions. So as long as you haven't made an error along the way, both should be good answers to this one. All right, thanks for watching.